It is in another place on the planet, completely isolated in the middle of the Pacific, in Hawaii, that there is an observation site as important as those in Chile. The highest peak in the Pacific at 4,207 meters, the dormant volcano Mauna Kea hosts a collection of international telescopes at its summit. Here, there are many research programs, but some telescopes have chosen to focus their efforts on the issue of extraterrestrial life. Every morning, Yuko travels the Saddle Road, a road carved through the volcanoes. Coordinator of the Subaru Telescope, the Japanese national telescope, she is scheduled to meet today with a French team that is developing a new instrument dedicated to the search for life elsewhere.
So when I first came here as an astronomer, I was so amazed by the number of stars. I saw Milky Way galaxy clearly. I saw hundreds of stars, and every 5 minutes I saw shooting star. And it was just wonderful experience. I really felt the universe. Universe was so close to me. So I feel like Mauna Kea is the gateway to the universe. Japanese astronomers wanted to build world-class telescope. And Japan is so humid. Even though we have Mount Fuji is not a good place to observe stars because of high humidity. And that's why the Japanese astronomers came here to build Subaru Telescope.
We have dreamed of it for a long time, but today scientists are convinced of it. We will soon discover signs of extraterrestrial life. From hypothetical, the existence of life elsewhere has become probable. The question is no longer whether we will find it, but when. And Olivier Guillon and his team would like to be among those who will participate in this great discovery.
Hello.
How are things going today?
Quite well. The main cameras are all running. The interferometer, Stephen is doing some final work, but it seems to be running. That's the detector for it. So it's fiber fed. So we have fibers going from the instrument under here to here.
Are you going to use this tomorrow?
Yeah.
Our long-term priority is the search for life in the universe, the search for habitable planets in the nearby sky. So in this area, there is always a need for new technologies. And we're really here at the forefront of these technologies. We work with several international groups that are developing new detectors, new cameras, new light handling techniques, which we integrate into the instrument. We're really in this perspective of searching for life, actually.
If we open, what is your next target? If we open, what's the brightness of your target?
Brightness is 7 or 8 magnitude.
Okay.
R-band.
Okay. If we open, then it will be fine because these are quite bright for our wavefront sensor. So.
But
At the Subaru Telescope, observations are mostly conducted in tandem. Tonight, Japanese astronomers in search of planets that could harbour signs of life have prepared a whole list of potentially interesting targets. They will be able to see live images taken by the telescope. Olivier oversees the program, hoping one day to find the first forms of extraterrestrial life.
Earth-like planets around other stars are not science fiction. They exist, and there are many. We think that between 10 and 50% of the stars in the sky have a rocky terrestrial-type planet at the right distance from them to have a temperature like the one we have on Earth. The number of potentially habitable planets in our galaxy is probably in the order of a few tens of billions. The big question is, what is on these planets? Is it an atmosphere with oxygen, water? Is there liquid water? Is there life? It is very difficult to anticipate what we will see, because we are surprised. Nature has more imagination than many scientists. The search for life outside our solar system is a huge philosophical question, since it touches on our origins, our place in the universe. It also touches on aspects of religion. These are universal questions that human beings have been asking themselves for a very long time. And the discovery of other life forms will be something that will change science. With a little luck, maybe we'll get in touch with our neighbors.
To prepare the future of astronomy, the Hawaiian archipelago is also participating in the giant telescope race. At the top of Mauna Kea, after 40 years of loyal service, the CFHT, the French, Canadian and Hawaiian telescope, is being totally overhauled.
We are one of the oldest telescopes, built in the 70s. It'd be nice to have an instrument come in, basically from the start again, which is what we'll be doing, and then be able on the ground floor to see how everything goes together, and yeah, we'll see what happens.
The MSC project, Mauna Kea Spectroscopic Explorer, will transform the current 3.60-meter optical telescope into a 10-meter telescope that will be entirely dedicated to analyzing the composition of light on about 10,000 objects in the sky. In the CFHT's design offices, the design of the future telescope is already well advanced, and one of the scientific coordinators of this ambitious project is the Frenchman Nicolas Flaget.
Hold your breath. This is what MSC will look like in the future. We'll just keep the building at the top. This whole part here is the same as the current part. All this exists now. What has changed is what's above, so the dome and what's inside, which is the telescope. That's the telescope in its current design. The big boxes on the side are spectrographs. You can see the main mirror. In 10 years, we know that there will be giants, the 30-meter, the 40-meter, the ELT, the GMT, the TMT, which will all be part of the astrophysical landscape. And we know that there will be a need for a telescope like MSC, which will take spectroscopic measurements, and only that. One of the great discoveries of recent decades has been dark matter, dark energy. We know it exists, but we don't know what it is. Most of the universe, we don't know what it's made of. We don't know where it comes from. So MSC will have the opportunity to force a little bit the models that define dark matter, just to know what energy and matter there is in the universe. To be able to constrain its models of dark matter and energy, that is one of the first aspects. The other aspect is closer to us. We're going to look at our galaxy, and we're going to look at all the stars. We're going to look at millions of stars to see where they come from, what their chemical composition is. And we'll be able to put them in a family and know that this star and this star were probably created in the same place at the same time, and these stars too, and these stars too. We're going to try to roughly reconstruct the history of the galaxy by looking at the stars, by looking at the children of the galaxy, by trying to find out where these children come from, how they travel through the galaxy, and by trying to go back in time. What is the history of the formation of these stars and therefore of the formation of the galaxy? These are two of the major areas that MSE will explore.
Currently in the design phase and seeking funding, the MSC project should be completed in 2025. In the meantime, as every evening, Callie arrives to sit in front of the consoles of the current telescope. This young astrophysics graduate will pilot it once again for about 10 astronomers, who will retrieve the data the next morning. These observations will undoubtedly be part of the last ones of this 40-year-old telescope.
So currently I'm opening the dome and I'm watching it through the webcam so that we know that's a safe environment, so I can see that nothing's falling on the telescope to ensure the safety essentially of everything going on up there. Everything is completely under control. So far I see no problems as I'm watching this, so it looks like it should be okay tonight.